guys, welcome back to a new video. And in today's video, our topic is the allotrope of sulfur, or we can say the allotropic forms of sulfur. So if you have not known what allotropes is, so in our just previous video, we have discussed what are allotropes, and we have discussed the allotropes of carbon. So if you haven't checked out those videos, do check it out. In today's video, we are looking for the allotropes of sulfur. So here, first of all, there's a beautiful picture which shows you a similar sort of yellow sort of substance. This is all sulfur. Uh, I have told you that what are allotropes, the one which are pure elements, but their properties are different due to the arrangement of atoms in them. So their physical properties get differentiated. So these are all atoms, but the arrangement of atoms is different. So we've got different forms. Some are bored, solid, some are powdery form, etc. So we have discussed all this on previous video. Just in today we're looking into more details or focused on the sulfur. So you can simply say that we got four allotropic forms sulfur, and probably we will maybe distinguish at the end of the video which one is uh, the what sort of allotropic form of sulfur. So without wasting time, let's start. First of all, uh, here we have got that we have got a large variety of sulfur allotropes, and this is very true. And in majorly we gonna study around three to four types of sulfur allotropes. Probably you're gonna study all these types in your higher studies or when you get into universities. But for right now, just me give you an idea that a lot of allotropic forms do this as well. Now we have got a color range as well, like uh, violet, blue, red, orange, yellow, orange, and all that stuff. And among these all, uh, this one is uh, common of all. S6 is common of all. The yellow orange color. This is uh, common, very common. And these all are S2Vs. There are two atoms. S3 atom arrangement. S4 means four atom arrangement. All this stuff. Probably you can understand this when we go further. Okay, some of these allotropes can be further divided into different forms based on their crystal structure. Alpha acid and beta acid have different densities, and the melting points. What does this mean? Okay, this means that some has got alpha chains while some has got beta chains. This depends on arrangement. Like if you haven't checked out uh, my biomolecule chapter, from that you can get an idea what alpha and beta form is. So from there you can check it out. And the difference between alpha and beta form, there would be only the sides arrangement of atom would be different there. The right side will be shifted to left side, or the OH atom arrangement would distinguish this thing. While they have got different densities and melting points. So there is a complete study based on the sulfur allotropes, and uh, these the, the from S2 to S7, they have got further more allotropic forms. So this is a large field. Naturally, again, sulfur is alpha acid. Now here you got to know that okay, this I want to include over here that S2 to S15. This is also very common. And here again you got yellow shades of sulfur. Uh, Here you're gonna see that we have mentioned about that from S7 to S15. So S2 to S15 there is a large field working behind it. Okay, naturally occurring is alpha acid. This is an MCQ based question that they might ask it, which is uh, natural sulfur forms, that is alpha acid. 8 sulfur atoms in a Parker drink, often called grown. This forms sulfur in water. Okay. Uh, Let me see if I just found a picture of it. Okay, this one is, we're gonna say that we've got 8 different atoms, S8 arrangement, and this is alpha acid sulfur, and this is grown arrangement. Yes, this is. I want to zoom in into it. You see, this is a grown arrangement. Let me make it more clear for it. This is grown arrangement. If sulfur is heated up to 400 degrees Celsius, then rapidly cooled, we got plastic sulfur. And yes, this is also very common. Like if we are heating one of the allotropic form sulfur, and we just cool it, so a new form of sulfur will be there. That is plastic sulfur, and that is also called the the gamma sulfur. Okay, so this is, you can take an example of when you just melt a candle and the wax is cooled. So there's again formation of solid sort of substance. Same is with this, but the temperature is high. Okay, so here you got another diagram, electrodes of sulfur, plastic sulfur, and we just studied this. And uh, sulfur, okay, rhombic sulfur. This is very common type of sulfur. This is the rhombic sulfur is also called as the alpha sulfur, and it has got large crystal compound of acid molecules, and this is bright yellow, and it is present below 98 degrees Celsius. This is very important point I'm telling about this rhombic sulfur. Like this exists below 98 degrees Celsius, 98 degree Celsius, and it is stable at room temperature, of course, 25 degrees Celsius, and it exists in nature insoluble in water, and uh, it is non-polar bad conductor of heat and electricity, and it has got acid, so we can say that it has got the crown shape. While we have got monoclinic sulfur, that is also called, okay, the rhombic is the alpha form, and the monoclinic sulfur is also called the beta form. And monoclinic sulfur is also called prismatic sulfur, and fine needle-like crystals. Monoclinic is derived from the word needle, so therefore needle-like. Here you can see in the diagram over here, clear needle sort of structures are there, and below 96 degrees Celsius, the rhombic sulfur exists, while above 96 degrees Celsius, the beta sulfur or the monoclinic sulfur exists till 119 degrees Celsius, and after 119 degrees Celsius, the monoclinic sulfur is converted into another form, and which is not stable. Crystalline allotrope unstable at room temperature. Of course, this is above 96 degrees Celsius. I just did a mistake over here. This is 96 degrees Celsius. 96 degrees Celsius, and uh, you can see the insoluble in water and soluble in organic solvent, and non again this is S8 compound, and uh, the next, moving forward, we've got other running molecules such as S7 and S12. Uh, Here is the plastic sulfur, that is, like plastic sulfur, we have got super cool form of sulfur or the gamma sulfur, and this is amorphous allotrope of sulfur, and it's just like a plastic sort of substance, and not considered as a true allotrope of sulfur because the atoms are arranged in random manner. This is very important to notice. Now let's move forward. Here you're gonna see some sort of allotropic arrangements. This is the chrome sulfur, which you can say the rhombic sulfur or the beta sulfur, most common one. And we have got some other. This is needle sort of. So this is monoclinic, and we have got the ordinary sulfur, which is the rhombic. We can say other very other forms. And here you can see 12 row solid sulfur, 8-membered rings, but different crystal form, monoclinic rhombic. If liquid sulfur is cooled, quickly divided to form plastic sulfur. We will discuss this thing. This is a chrome formation, and this is a plastic sulfur, and this is a monoclinic sulfur. This is a rhombic sulfur. While here you're gonna see that this is the S2. You've got two atoms, S3, and again S3. I have told you before that in S3 we got furthermore types. In S4 we have got furthermore types. So here is the table: S4D, S4C, S5C. Different sort of elements. And this is S8. and S7 remember this forms a ring shape, while uh, the S8 is most common, or we can say that this is found in chrome formation in the form of a monoclinic sulfur or the rhomic sulfur etc. So I do hope that you've got the concept. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.